Good morning, one and all. So let us start today's class. In the last class, we have seen what is a perceptron and what is the main difference between MP neuron and perceptron. The main difference is in perceptron we have weights associated with each input. Now, so before proceeding further, let us discuss what is a dot product and what is the angle between any two vectors. So dot product means, so I have taken two vectors, something like this, vector w and vector x. So this can be written as w transpose into x. So remember, this is the dot product. Okay. Now this will be same as summation I equal to 0 to n wi into xi. This is the dot product of any two vectors. So we have discussed these things in our ADC course also in the last semester, in the last year. Okay. Now, so what is this w and x? They are of dimension n plus 1. So w are the weights of the inputs. What are they? w0, w1, so on, wn. What is x? X is the input, set of inputs. That is x1, x0 that is always equal to 1, x1, x2, so on, xn. So this is a dot product of two vectors. Now this can be further written as, you might be knowing this anyway. So dot product can also be written as w dot x. This can be written as mod w into mod x into cos of alpha. You know this, right? What is alpha? Is angle between two vectors. This is a norm or mod, which means, what is the mod w means, or norm w means? Square root of w0 square plus w1 square, so on. Okay, that is a mod operation, right? Now, so when the dot product is 0, what do you say? When the dot product between any two vectors is 0, which means they are perpendicular to each other. So w is perpendicular to x, which means, so obviously from this diagram, from this equation, so whenever this is 0, obviously cos alpha is 0. Okay, what do you mean by this? This is 0 means this is 0, cos alpha is 0. When cos is 0, when alpha is 90. So cos alpha equal to 0 means alpha implies it is 90 degrees. Okay. Yeah. So this is the finally the dot product or angle between any two vectors. So from this equation, what is cos alpha? It is w dot x, or that is same as, okay, what is cos alpha? W dot x by norm w into norm x. But what is w dot x? It is also equal to w transpose into x. Okay. Now what is alpha? If you take alpha here, what is alpha? It is cos inverse of this quantity. Same thing is, or cos means or cos inverse. Alpha is cos inverse of w transpose into x by mod w into mod x. Now this is how we denote the angle between two vectors. Okay. So this is the angle between vector x and vector w. That is alpha. If alpha is 90, then what happens? So they are somewhat like this. They are perpendicular to each other. Cos alpha is 0, that is alpha is 90 degrees. Okay. So that is a brief introduction to dot product between any two vectors and the angle between any two vectors. Right. Now, so let us get into our topic now. So now we will study a perceptron learning algorithm. So in the last class we have seen, so each and every perceptron will have some weights. W naught that equal to minus theta, it's called bias, W1, W2, so on, Wn. We have to learn these weights. We need a mechanism or algorithm to learn these weights. Okay. Now here, so let us take a simple example of movie example. Okay. Now suppose, so I want to predict whether I should watch a movie or not. Okay. So here in the perceptron we have n inputs. Is it clear? X1 is an actor, some ABCD actor. Okay. X2 is the genre of the movie. Thriller is the genre of the movie. X3 is the director of the movie. Some XYZ director. X4 is the IMDb rating, scale to 0 to 1. It is in the between the value 0 to 1. This is the IMDb rating of a movie. Okay. So lastly, a critics rating, 0 to 1. Okay. So I have taken all these factors into consideration to predict whether to watch a movie or not. Okay. Here no. So here this is a binary classifier. Why? Because here we are verifying whether to watch a movie or not. So if we wish to watch a movie, the output is 1, otherwise output is 0. Okay. Now here, so basically we have a list of movies with classes or labels. Let us take movies, list of movie names with class. Okay. For each movie we have set of n inputs. Okay. Suppose a movie A. So what is the class or label? So suppose we are given a list of m movies and label a class associated with each movie indicating whether the user liked this movie or not. It's a binary decision, which means we have a data. We have a past data of movies. Okay. So I am taking m movies, A, B, C, D up to m, something like that. So A. Now what is the class of that movie? Whether I liked or not. If I liked, I will write 1. If I dislike, I write 0. I will take next movie. So this is my interest. Okay. Next movie. So I will write whether I like the movie or not. If I like the movie, I will write 1, otherwise I will write 0. So like this we have a data. This is a movie history. How many movies? M movies. A, B, C, D up to M. For each movie I have a label. Label means 1 or 0. Label 1 means I like the movie. Label 0 means I don't like the movie or dislike the movie. Okay. So here we have two classifications when it comes to movies. What are they? 1 or 0. So if it is 1, we say positive. If I say movies which I like are said to be a positive class. 0 means negative class. I have two classes of movies, positive, negative. Positive means movies which I like. 0 means movies which I don't like or which I dislike. Okay. So like this we have a data. Now from this data we have to learn the weights. Okay. Now further we represent each movie with n features. As I told you, now for each and every movie we represent with n features. What are they? X0, X1, so on, Xn. So what is X1? I am assuming some ABCD actor. X2 is the genre of the movie, is a thriller. X3 is the director, some XYZ director. X4 is a rating, IMDb rating, and so on, Xn is a critics rating, scale to 0 to 1. Okay, these are the features of each and every input. Each movie with n features. Okay. So we will assume that the data is linearly separable and we want to learn our perceptron to make the correct decision. Okay, so here I should make the correct decision based on the data, the training data to the perceptron. Okay, how it can make correct decision? By choosing the proper weights. Okay, so basically we have to learn these weights in a proper way. Now, one more thing, here all these x0, x1, xn need not be Boolean. In case of MP neuron, we have taken all the inputs to be what? Boolean. Boolean means 0 or 1. Here they need not be Boolean. Why? Because, so suppose x1 is actor is ABCD. You can say yes or no. It can be Boolean. x2 can be Boolean. x3 can be Boolean. But x4 need not be Boolean because the rating can be any value between 0 and 1. So here x4 is a real value. In the same way xn also a real value. Okay. So here all x1, x2, xn need not be Boolean. So they can be Boolean and they can be real values also. Okay. So finally, right. So we want to learn the weights of this perceptron. So for this we need algorithm that is called perceptron learning algorithm. Okay. So simply we have to classify the movies properly. Right? Okay. So this is the algorithm. Now, as I told you, label 1 means positive input. We call P. Label 0 means negative input N. As I told you, each and every movie is labeled with a class with a label with 1 or 0. 1 means positive, 0 means negative. Here P, here N. Okay. Now, so we initialize W randomly. We initialize W randomly. Right. So here, what is the job of this algorithm? We have to choose W properly so that this algorithm can classify our movies properly. Classify properly means it will divide a positive input and negative inputs properly. Okay. Right. So here first thing is while not convergence we are writing while not convergence. Now what is convergence means? So when our algorithm is not making any errors on the training data. So algorithm convergence means it does not make any more errors on the training data. Okay. Now, so this is algorithm. Now, so we pick random X that belongs to P union N. Okay, randomly we pick one movie. Is it okay? If X belongs to P, P means positive. Okay. Now remember, so in our perceptron algorithm, if something is positive, what do you write? What is the logic? What is the division rule? Okay. So where I written this? Yeah. So let me write here. So in the last class we have seen. What have you seen? What is division rule? Perceptron division rule. What have you seen? So output is 1 if weighted sum Wi xi is greater than or equal to 0. Output is 0 if weighted sum is less than 0. But just now I told you this is equal to what? W transpose into X. So now the modified rule will be output Y equal to 1 if W transpose X is greater than or equal to 0. Output is 0 if W transpose X is less than 0. Now W transpose also, this also is equal to, W transpose X is also equal to W dot X, dot product. Okay. Now what I am doing is, yeah. So X belongs to P and W dot X is less than 0, which means we are making an error. Okay. If X belongs to P, positive means Y should be equal to 1. If Y equal to 1, what do you mean by this? This should be greater than 0. What are you doing? So X belongs to P means Y is 1, but we are writing W dot X less than 0. Now we are getting error here. We are making an error. How to correct it? We add X to the W. Okay. We continue this iteration. So this is one possibility of error. So in other case, what may happen? If X belongs to N, which means X belongs to negative inputs, what output should be 0. Negative label. Label 0 means negative. So if Y is 0, what should happen? This should be less than 0. But here what happened? What I am writing? This is greater than 0. Again I am making error. So here what I am doing? What a correction? I am subtracting X from the W. So this is the algorithm. Okay. Now when X belongs to P and its dot product is less than 0, that is case 1. Okay. This is the first case. This is second case. X2 belongs to P and the dot product is less than 0. Case 2 is X belongs to N and its dot product is greater than or equal to 0. Now in these two cases we are getting error. To overcome the error, we are updating the vector W. Okay, we have to learn the weights properly. Okay, otherwise we don't touch the W at all, because case 1 and case 2 are violating the very rule of the perceptron. Okay, so in these two cases we update the weights, because there is something wrong with the weights. I told you we have to learn the weights. So we are getting error in these two cases, which means there is a problem with W. It is not properly defined. So we should update the weights, or we do the correction to the vector W. What a correction? In the first case we add X to W. In the second case we subtract X from the W. These are the updated values of vector W. Okay. So we are adding X to W in case 1 and subtracting from the case 2. Okay. So this algorithm converges when all the inputs are classified correctly. So that is normal. Okay. So this is algorithm. Okay, we are updating the values of weights. Now, so before proceeding further, before proceeding further, let us discuss the geometry of the perceptron in this case. Okay, so we can rewrite the perceptron rule as like this. I told you already. Okay, now we interesting. So now what is the line? What is the decision boundary here? W transpose X equal to 0. This is a boundary which divides into two halves, which divides the space into two halves. Which means now here this line is the boundary. This dotted line is the boundary. Okay. Now it is dividing the space into two halves. Suppose if I say W transpose into x equal to 0 means what? W dot x equal to 0, which means W is perpendicular to x. Okay, here there is the same meaning. Here this W, this vector, is perpendicular to this line. Is it okay? So because W transpose x equal to 0 or W dot x equal to 0. Correct? Now what is the angle between them? What is this angle? Is 90 degrees. Because they are perpendicular to each other. Now one more thing. So here this is cos alpha. I told you already. So from this equation I can say this: cos alpha is proportional to W transpose into x. Okay? Because the numerator is anyway a real number, some positive number. Okay? Now if W transpose x is positive, okay, which means cos alpha is positive. If cos alpha is positive, means alpha is less than 90 degrees. This is simple trigonometry. Similarly, if the W transpose x is negative, this is negative, this is negative. If this is negative, cos alpha is negative. So when in that case, alpha is more than 90 degrees. Is it very clear? Okay. So remember this. And we are writing from the basics of the angle between two vectors, nothing more than that. Okay. Now, so this is the boundary which is perpendicular, which is the line is perpendicular to the vector W, which means each and every point on this line is perpendicular to the vector W. Okay. Or simply I can say this line is perpendicular to vector W. Yes, okay. Here, so now condition is if x belongs to P, if x belongs to P, so in this case I have taken 3 positives and 2 negatives. P1, P2, P3 are positive inputs, N1 and N3 are negative inputs. Okay. So they are shown in the blue color and they are shown in the red color. Okay. Now, if x belongs to P, what about alpha? What about alpha? What is alpha? So suppose let us take alpha is angle between vector W and input points. Okay. Okay. Now when x belongs to P, so then generally x belongs to P means positive. What will happen? When x belongs to P, so what do you say? When x belongs to P, generally what should happen? So W transpose x should be greater than or equal to 0. Okay. So if it is positive, what about cos alpha? Just now I told you. So whenever this is positive, cos alpha is also positive, alpha is less than 90 degrees. Which means the angle should be less than 90 degrees. When x belongs to negative inputs, obviously alpha should be more than 90 degrees. This is the logic. Okay, let us see here from the figure. So what is the angle between P1, P2, P3 and W? Okay, so it is less than 90 degrees. Angle between W and P1, P2 and P3 is less than 90 degrees. So the angle between the vector W and the positive points is less than 90 degrees. You can clearly see from the figure visually. Now what about angle between W and these negative points N1, N2, N3? It is more than 90 degrees. It is very obvious from the figure. Okay. So for perfect classification, please remember alpha should be less than 90 for positive inputs and it should be more than 90 for negative inputs. Is it clear? So that is the basic rule. Now we are getting into the angle parameter. Okay. So now we have to choose this W properly so that it makes an angle of less than 90 with the positive inputs and more than 90 with the negative inputs. Then there is no error. Otherwise there is error. That is simple logic now. So we conclude that. So the angle between W and X should be less than 90 when X belongs to P class. The angle between them should be more than 90 when X belongs to N class. So I am simply writing, this is simple logic. If X belongs to P class, positive class, the angle alpha should be less than 90. If X means capital X belongs to negative class, alpha should be more than 90. Now this is a perfect classification. It classifies the movies properly if it is so. Okay. Now for this we have to choose this W properly. We can only change W. Everything is fixed. All the inputs, everything is fixed. Okay. Otherwise it is very clear from this figure that there is a line. Okay. So this line, the points which lie above the line are positive points. The points which lie below the line are negative points. It is clearly classifying the positive points and negative points, P class and N class points. Okay, that is one way of looking at the problem. But so remember this angle is also very, very important. Now, so how to, now let us see. Now, so let us go to algorithm. In algorithm, what happened? We are getting errors. Okay, X belongs to P and the dot product is less than 0. Obviously, when X is positive, the dot product must be greater than 0 or greater than equal to 0. So we are getting error. So to correct the errors, we are updating the W. How we are updating? Addition. Here we are updating the W by subtraction. Because these two are the cases we get error. Case 1, case 2. Okay. Now, so what happened? What is exactly happening in the case 1 and case 2? Let us look at the case 1 and case 2. Okay. In the case 1, what is happening? X belongs to P and the dot product is less than 0. It means that the angle between X and the W is greater than 90. Okay. Understand the case 1. Okay, let me write here for your understanding purpose. Case 1. So X belongs to P, but the dot product is less than 0. So whenever the dot product is less than 0, cos alpha is less than 0, which means alpha is more than 90. But so whenever X is positive, alpha should be less than 90 degrees. Okay. In case 2, what is happening here? X belongs to N, negative N class, and the dot product is greater than or equal to 0. So when the dot product is greater than or equal to 0, cos alpha is greater than 0, which means alpha is less than 90. But for negative inputs, we have seen that alpha should be more than 90. Now this is a contradiction we are getting. What happened here? So in the case 1, actually what should happen? Alpha should be less than 90, but we are getting it is more than 90. Okay. In case 1, actually we are getting more than 90, but it should be less than 90. When x belongs to P, it should be less than 90. But because of this error, we are getting more than 90. Okay. In the case 2, reverse. Actually, it should be more than 90, but we are getting less than 90. To overcome that, we are updating the W. Here, what updation? W is nothing but W plus X. We say W new. Here, what is updation? W new equal to W minus X. We are updating the table, W table, so that these things will be reversed. Okay. So W in the case 1, this is case 1, this is case 2. In the case 1, so alpha new, so W new is W plus X. Now as I told you, cos alpha is proportional to, I told you already, let me write here, generally cos alpha is proportional to, please make note of this, W transpose into X. Obviously, cos alpha new is proportional to W new transpose into X. Very clear? Now what is the W new transpose? W plus X transpose into X. You can also write W transpose X plus X transpose X. What is W transpose X? Is cos alpha. So now I am writing cos alpha. So this is positive. Please remember this. X transpose X is positive. Which means what? X dot X. What is X dot X? Dot product of a vector with itself. Mod X or norm X. It is positive. Now what happened here? So cos, this is positive, that's why cos alpha nu is more than cos alpha. Cos alpha nu is more than cos alpha. Is it clear? So you know already, cos is a decreasing function of its argument, something like this. Okay, which means, so which is more, alpha nu or alpha? Alpha nu is less than alpha, because cos alpha nu is more than cos alpha. So the reverse will happen, right? It's a decreasing function of its argument. Right? Now here what happens? Now second case, what is alpha nu? Sorry, what is W nu? W minus X. So same thing. Now here cos alpha nu is less than cos alpha, means alpha nu is more than alpha. So these are new angles. New angle is less than the old angle. Here new angle is more than the old angle. So here what should happen? Same thing should happen, no? Here alpha is more than 90, but it should be less than 90, which means we have to decrease the alpha. In the first case, alpha should be less. So that's why the new alpha is less than the old alpha. Case 2. So alpha should be less than 90, but it should be more than 90. It is more than 90, it is less than 90, but it should be more than 90, which means we have to increase alpha. So the new alpha will be more than the old alpha. We are increasing the alpha. So we continue like this until we get a convergence. So the cycles will repeat until we get a convergence. So that is how our new updation works. Now, so let us see a toy simulator. So we have something like this simulator. How it works? How we update the vector W? How we correct the errors? Suppose let us take this is a W initially. So I know already for P class, for a positive class, the angle between vector W and vector X should be what? Less than 90 degrees. For P class, alpha should be less than 90. For N class, alpha should be more than 90 degrees. For a perfect classification or for convergence. Suppose W is here. So just from the figure, visually you can say that it is exactly opposite of what we wish. It is making this vector. It is making what angle with N1 into N3? Less than 90. P1 into P3? More than 90. Okay, just from the figure it is obvious that this vector is making less than 90 degrees with the negative points, N class points, more than 90 with the what? P class points. So it is exactly reverse. In this case, now we update it. What we do? We update it. Suppose somewhere here, next vector is somewhere here. What about this vector? It is also not properly designed or not properly chosen. So next we change the rule. We do corrections. Suppose next W is here. It is also not properly classifying. W next is here. This one. It is also not properly classifying. Now we are here now. Now this is our W vector. Now this vector is properly classifying the points because it is making less than 90 degrees with the P class points and more than 90 with the N class points. So like this we will do the updation of the vector W. So we have chosen first vector here. It is not working. We do corrections. Next we go on here. What a correction? It depends upon the case. Correction can be W plus or minus X. Okay. So next we go on here. It is also not correct. We go on here. Not correct. Go on here. Not correct. So we are here now. So now this perfectly matches our requirement. So we stop here. Okay. So like this we do the updation or iteration of the vector W so that it classifies the vectors or inputs properly. Okay. Now this algorithm has converged. Finally it converges. Now we run algorithm by randomly going over the points. Okay. This is about how the Perceptron learning algorithm works. So please remember it is updating its values, that is W values, based upon the errors. So this is how we are dealing with the angles here. Geometrically we are dealing with angles. Okay. So right. So we stop here. Thank you.